the goal today is actually nothing new. So I have no new goal. We're gonna be taking 3A and applying the stuff that I put up yesterday. So just remember with this, these are really important. I know probably you need to for sure know a Taylor polynomial, that you're using it to approximate about a given center of function we already know, right? You gotta know that. We'll write that out in a little bit. And then you need to be sure, next up, the difference between Taylor and Maclaurin. That's easy, right? Maclaurin is centered about 0. Sometimes they'll say a Taylor centered about 0, so you're really doing a Maclaurin. The only reason I'm stressing that a lot is because on the AP exam, they like to go Maclaurin and expect that you know what that means. So it's mainly knowing the Maclaurin more than the Taylor. The biggest thing is that you've got the general form down pat, that you can generate it. I'd almost suggest on the next few worksheets, you just write it across the top because you're going to be using it both forwards and backwards. So we'll put that at the top of those 5 problems. And then yesterday I had you on that note card. We did sine, cosine, and e to the x. So just to review that, what does sine x's expansion start with? Then what? Minus x cubed over 3 factorial plus x to the 5th over 5 factorial, etc. We'll worry about the general term later. We're still just doing approximations. Just when you're doing your worksheet, be careful if they tell you, Jenna, to do 4 terms versus a 4th degree. So watch out for that, okay? It's different. Cosine x's, again, are the evens. So cosine 0 is 1. It starts at really 1 x to the 0 over 0 factorial, but that's just 1. And then we do minus x squared over 2 factorial plus x to the 4th. E's is nice. There's no alternator, right? Just be careful you don't miss 1. Because I know you know it starts at 1 because you did the 0 is 1, but it goes 1 plus what? X and then x squared. Last year some people would miss the x. They just go 1 plus x squared over 2 factorial. So remember there's an x in there. Other than that, today we're just going to practice it. So we're going to do 5 together and then I'm going to let you go on worksheet 3A and that will be due tomorrow. So let's go do those 5 together. I will call on you. I have my headset on, but I'm still going to call on you. Do we have Leonard back yet? No. All right. So you're going to have to use these. You need to understand the model. So let's go up here and write it briefly. Your polynomial of nth degree of a function is going to be f of c. And we did this. I'm going to write it really fast. You should be able to generate this now, since I had you do it yesterday. Technically over 1 factorial, but we don't need it. All right. So I'll go pretty fast here. Over 2 factorial plus, depending on what they tell you n is, we would then have, I think I had Max do it, the general term yesterday, right Max? F nth derivative at the center, x minus the center to the nth power over n factorial. This we're going to be using quite a bit. All right. So I gave you a polynomial expansion already. So what I'm telling you is that this is a Taylor polynomial of the 5th degree that I centered at 0, so I could have called it Maclaurin. I want to know what the 4th derivative was at 0. So really what you're going to do is say this. This is going to be in control, correct? And you have 3x to the 4th. And what that got generated from would have been 4 here and a 4 here. And your center's at 0, right? So it would have been the 4th derivative at 0 over 4 factorial, x to the 4th. So this right here generated a 3. That's what that did. Are you with me? So how would I figure out what the 4th derivative is? Just do, again, I don't even really need this. I just was showing you that it's the 4th coefficient, and the coefficient would be 4th derivative over 4 factorial. That 4th coefficient ended up being a 3. So how do I figure out what the 4th derivative was? 4 factorial times 3, yeah. So the 4th derivative at 0 must have been 3 times 4 factorial. What is that? 3 times 24, 72, yeah. So 72 must have been what the fourth derivative generated. And then that would have been x to the fourth over 4 factorial, and it gave you a 3. So it works, you have to work with them forwards and backwards. Number 2, this isn't one that you have memorized, plus those ones that you have memorized only work about the center of what? 0, so you can't morph them. So this one you'd have to create in full. I might just start it. But this one you have to start with the model, and you have to understand that you're going to be doing a third degree. So technically you're going to say my third degree Taylor polynomial is going to equal, and you would say f of what? F of what? 1, yeah. 1 plus f prime at 1 times x minus 1. And I'm writing this out. I mean, I'll stop next week writing it out every time. But for a while, it does help to write it out. Because if you forget the model, the whole thing falls apart. And unfortunately, I've told you the biggest task for you guys is you have to remember everything without a note card for 2 full semesters of college math. That's a daunting task, right? So we're just going to keep writing it out until it's embedded in your brain at least for a while, and then it'll probably leave it. That's my model for my third degree, right? So how do I start generating it? Because yesterday you weren't generating them, you were modifying existing ones. So what would I do first? Go ahead and tell me. Pumpkin, go ahead and tell me how I'd start this. I know, that's what I call them. How do I start it?
I would try to find derivatives.
Not even yet. What do I generate first? F of 1. Yeah, so really what I need to create is numbers for these coefficients. That means I need to start taking derivatives, but before I do that, I need to get, I just start on the side and I write f of x, and you can make a chart, you can make a table. I just indent, and I'd say f of 1 is ln of 3. So this is going to start with ln 3. There's my first one. All right, then I'll just pick on 4 of you. Max, can you remind me how to take the derivative of the natural log of 4 minus x? Because I can't put a 1 into it until I need to put a 1 into it, but I can't do it till it's a function.
How, 1 over 4 minus.
Yeah, it's 1 over u, right, times the derivative of u, which is negative 1. So at 3, that's going to be a what? I mean, sorry, at 1. Yeah, that's going to be a negative 1/3. So if maybe just write it off to the side. F prime at 1 would be a negative 1/3. If you then want to go put it in your model and create it as you go or create it as at the end, that's all up to you. All right, just be careful with your signs when you're generating yours yourself. So Max has got this one. I would highly suggest that instead of viewing this as a quotient, write it as negative 1 times 4 minus x to the negative first. So go ahead, bestie, give me the second derivative of x.
X over 4 minus x squared.
X. No, I'm not doing that. I'm writing it as negative 1, 4 minus x to the negative 1, and I'm going to take its derivative. So reboot that. There's no x anywhere. I mean, I could do quotient rule on here, but it wouldn't give me what you said. Bring this out front. What do you get?
Oh.
A 1,
Yep.
right? Over 4 minus x to the negative 2, and then tell me what's wrong with mine.
You didn't do the
I didn't do the gut, so it's actually negative again. It's going to be at 1, right? I'm going to take this one on out to the end. At 1, I would put in a 1, and I get negative 1 over 3 squared, or negative 1/9. I'll go back up here in red, and I'd have a minus, but I'd have a 1/9 over 2 factorial. So who's my coefficient for my quadratic? Yeah, 1 over 9 times 2 factorial, or 1 over 18 would be better. All right, last one up. You guys go ahead and do it. Generate your third derivative. Plug a 1 in. Give me the coefficient. And then I'm going to show you how to work backwards, because that's what really bugged people last year. Was they could generate it, but they couldn't, once it was generated, answer questions about it. Yeah, is it locked? Is it locked? That's just Apex not working right now. just work on something else, maybe work on freshman stuff for a little bit. When I'm done, I'll come. And if it still doesn't work, I'll send in a help desk class. Alright, did you get a coefficient? Third derivative? What would negative 1 over 81, right? It'd be 3 cubed at the bottom, and you'd still have a negative. Are you guys okay with that? With the derivative? Are we good? Yes? Jenna, you're good? Alright, so that would have been, let's go back over here. So you would have had a negative on that one, and it's 4 minus x to the negative 2. So it's actually 2 over what? Help me out, guys. You're going to bring this out front. You're going to have a 2, right? And you're going to have a 4 minus x to the negative third, and you're going to put a 1. I'm getting a 2 over...
You have to know.
There's got to be negative we got.
Yeah, negative, sorry. I'm getting a negative 2 over 27, right? So when I put that over 3 factorial, let's go do that nicely. Negative 2 over 27 over 3 factorial. Go ahead and clean that up for me. So that's going to give you a 2, right? What's going to cancel? Yeah, it's going to be 2 over 81 because this 2 is going to cancel with the 2 and the 3 factorial. So I'm going to, yeah, let's do that. 1 over 81. Ah, boom. My eraser's not working. Oh, dang it. All right. We'll just do it the long way. 1 over 81. Now, here's what they'll sometimes ask you. They'll say, watch me work backwards. Okay? It'll say, what was f triple prime of 1? How would you generate what we had for f triple prime? You'd go like this. F triple prime of 1, right, over 3 factorial had to equal what? 1 over 81 negative. And you'd solve that. So you'd multiply by 3 factorial and it reduces back to, you're nodding, back to the negative 2/27. That's what they struggled with last year, was being asked a question about what these were once it was already generated. These things are reduced, so they would invariably circle 1 over 81. And it's multiple choice. Do you see what I'm talking about? So make sure you realize that there was a factorial in there. All right, old question, I put review because this is on your next test. You have some multiple choice questions that are still about series and sequences, just like that thing holding all that stuff up. So this is a review. It says, from what values of k will both of these converge? This one's easier for me because what kind of a series is it? Geometric, and those only, this should say interview, should say integer. Let's fix my typo. That's a bad one. Google didn't catch it. Max did, but Google didn't. All right. So what are the only values that are positive integers that will make that converge? 1 and 2. Excellent. So for that one to converge, k would have to equal 1 or 2. And then we'll go see if both of them, one of them, or none of them work for the other. Well, the other one's that one I told you sticks around. This is an alternating one, correct? Without the alternator, it's 1 over n and it diverges. So it needs the alternator to converge. So which one of these won't cause alternating? 2 won't. Because if you raise this to the 2n, it's really 1 to the n, right? It's negative 1 to an even power. It might as well have just said 1 over n, and that diverges. But if it was a 1, then I'd have the alternator in there, and it'd be a convergent, conditionally convergent, right? Alternating series. So 1 is my answer. Another review. Sequences is what we started with the day 1 3 weeks ago before we started series. And because we've since done a bunch of series converging and diverging, you'll get this question wrong. And it's an AP question, and there's one like it on your next test. So this says, which sequence diverges? Remember, a sequence is a list. So remember that. If you think of what it is, for a list of numbers to diverge, what must they go to? Infinity. Yeah, if the limit was 10, what that means is I would continually be writing 10, and the sequence converges to what? 10. The series will diverge because you keep adding 10. So if you understand it, you still take limits. This guy's limit is 3/2. What that means for this sequence is I'm going to keep writing 3/2, and it converges. To what? The series, however, diverges by the what test? Nth term test. So I'm purposely messing with your head, muscle memory here. This guy, e to the n's limit as n approaches infinity. What does e to the n over n go to? That goes to infinity. You could consider L'Hopital's rule where that top is just going to blow out the bottom. That one's got an infinite limit. What that means is the sequence is going to keep growing and growing and growing and growing. How about this one's limit? 1. So I'm going to keep writing 1, comma 1, comma 1. The sequence converges to 1. So the only sequence that diverges is that one. Last up, and now back to what we're doing now. What is the value of cosine 2 using a 4th degree Maclaurin? So we're going to go like this. Cosine x is going to be approximated by, what does cosine start with? 1, yep, minus x squared over 2 factorial plus x to the 4th over 4 factorial. Boom. For cosine 2, I am going to approximate it with that, so I'll throw in a 2, and I'll get 1 minus 2 squared over 2 plus 2 to the 4th, which is 16, right? What's 4 factorial again? 24. That reduces to 2/3. When I clean it up, I can do that all in my head. I'm doing an approximation for cosine 2 without touching a calculator. We'll see how accurate it is in a little bit. -1, I'm getting a -1/3, or if I wanted to write it as a decimal like this. Go to your calculator right now and do cosine 2. I'm going to be pretty far off is my guess. Why? I only went to the 4th degree. I only did 3 terms, but so I only.
Oh, wow.
So what is cosine of 2 if you're in radians? Actual value.
Negative
0.416.
6 what?
1, 4.
Okay, good enough. Now, if I
3,
wanted to put a maximum amount of error on it, because this is an alternating series, let's talk about, because it says find the maximum error. The max error is going to equal, which means my error is always less than or equal to the maximum amount. Do you guys remember how we do that? I've had you list it back there with our Easter eggs a million times. Where do you go to get the maximum error? The first unused term in absolute value. So I go back up to this one, and it would have been minus, right? X to the 6 over 6 factorial, but what's my x? 2. And the absolute value is going to kill the negative. So I'm just going to say 2 to the 6th over 6 factorial. That will be my maximum error. Point what?
0, 8 repeating.
8 repeating. What that means is, if I took this and went up it and down it, this sum actually lives in there for sure. Done with that. All right, so I'm gonna, one last thing before I send you off to work. I think I have it on one more page. All right, I already had you list the general model. I'm not gonna do that. Remember, you can manipulate or modify existing ones. Just make sure the center isn't changed. Last step, this is super important. You might say, what was this stuff ever used for? Up until today, if you were to Google what is the antiderivative of cosine t over t, and just send it out to all the World Wide Web to figure it out, it all come back that it doesn't have an antiderivative. It doesn't. You would try U sub, you would try, it won't work. You can't definitively do it. So what they did historically is they put it in its polynomial form and then did the integral. And I'm going to have you do that on your worksheet. So watch me start and then we'll quit. If I want, you can do integrals, derivatives. We know cosines, right? Let's write that out. Cosine t would be, what does it start with? 1 minus t squared over 2 plus t to the 4th over 4 minus t to the 6th over, 4 factorial, boom, plus dot, dot, dot. If I divide it by t, this is really what I'd be integrating. 1 over t, right? Divide that by t, minus t over 2, plus what? T to the what? 3rd, minus t to the 5th. I'm just dividing, and I would go plus dot, dot, dot. That I can integrate, right? Watch. What's the antiderivative of 1 over t? Should know that. ln. Exactly. If I wanted to get an approximation, historically, when they couldn't integrate things, they had to do something like this. That would have been ln t minus, what's the antiderivative of t? T squared over 2, but there's already a 2 there, so that'd be a 4. Then this would be t to the 4th over 4. There's already, so you would do that, dot, 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 and then you'd go from 1 to 2. You'd plug it in, and you'd be super close to what your math 9 is. Do you think that might be how math 9 is programmed? Haven't you ever wondered how your calculator can do a math 9 on something we can't even integrate by hand? Don't you think it's probably shoving a polynomial in there and plugging stuff in? My guess is yes. All right, we're done. You can go work on 3A.